Welcome back, everyone. We're diving into something pretty fascinating today. Securing those LLM-driven query systems,
Ah,
the
yes.
ones that let you, basically chat with your database in plain English.
Right, right.
No more wrestling with complex code, just ask your questions naturally.
Pretty amazing, the convenience.
It is. But our source material for this deep dive, securing LLM-driven query systems, it kind of hints that this convenience, well, it might come with some security baggage.
Yeah, that's the catch, isn't it? You get this powerful tool to unlock insights from your data, but you got to be careful not to leave the back.
It's like, show me the last 10 orders, or find all orders placed after January 1st. Seems pretty basic, right?
Yeah, on the surface, totally. But remember, under the hood, the LLM is working hard translating that natural language into precise SQL code for the database. And even a tiny hiccup in that translation, well, it could have some major consequences.
Oh, I see. So, like, what kind of consequences are we talking about?
Well, imagine the system accidentally spills data the user shouldn't be seeing. That's a security breach just waiting to happen.
So it's not just about getting the right answer. It's about making sure the system's playing by the rules, respecting those access controls.
Exactly. And that brings us to well, a pretty interesting point about LLMs and SQL injection. You see, with traditional SQL injection, attackers try to sneak malicious code into those structured queries.
Right.
But with LLMs, things get a bit trickier because now we're dealing with the nuances of human language.
Hold on. So you're saying that asking a question in plain English could actually make the system more vulnerable?
Potentially, yeah. Because a clever attacker might craft a question that sounds harmless,
Oh, wow.
but it tricks the LLM into generating, malicious SQL code.
Okay, give me an example, because that's kind of scary.
Sure. Imagine someone asks, show me all orders where the customer name is John or R11.
Or R11, what's so special about that?
Well, that little snippet, that's a classic SQL injection trick. It can bypass security checks and potentially give the attacker access to all sorts of sensitive data.
That's sneaky. So how do we, like, protect against this kind of linguistic trickery?
One powerful technique is parameterized queries, sometimes called prepared statements. This is a bit technical, but basically, instead of directly plugging the user's input into the SQL query, we treat it as a separate parameter.
Okay, so even if the input has malicious code, it can't really do any damage because it's not part of the actual query.
Exactly. It's like putting a barrier between the user's words and the database's actions.
I like that analogy.
And then there's another important layer, object relational mapping, or ORM for short. Think of it as a security guard sitting between the LLM and the database.
Okay, so what does this ORM actually do?
It acts like a translator, converting those natural language questions into safe and efficient SQL statements. It also includes security checks to make sure the generated code only does what it's allowed to do.
So it's like a bouncer at the database door, making sure only authorized guests get in.
Exactly. But even with these safeguards, we still need to test the system with, well, unusual inputs, like logically impossible requests or extremely large numbers.
Wait, why bother with those edge cases?
Because LLMs, they can be a bit unpredictable, especially when they encounter something totally new. It's like probing the boundaries of the system, trying to make it crack. By throwing these curveballs, we can uncover hidden vulnerabilities.
So what happens if, we actually find a vulnerability?
That's where robust error handling comes in. Instead of crashing or just giving a generic error message, the system should gracefully handle those unexpected situations. Ideally, it should provide helpful feedback to the user, like, hey, this is what went wrong, try rephrasing your question.
It's all about that user experience, even when things go a bit sideways.
Precisely. We don't want users to feel lost or frustrated.
Right, right.
We want them to feel confident that the system is reliable and secure, even when they're pushing the limits.
And speaking of pushing limits, the document also talks about testing with, well, those super complex questions that humans love to ask. Those rambling requests with multiple conditions and constraints.
Ah, yes, the multi-part queries. They can be a real headache for LLMs.
Yeah, I can imagine.
They require the system to not only understand each part of the question, but also combine them correctly into a logical and efficient SQL query.
It's like asking the system to solve a multi-step word problem.
Exactly. And often the best way to tackle these is to break them down. implement what we call a decomposition step. But the LLM first splits the complex query into smaller parts, validates each part separately, and then puts them back together into a complete and accurate SQL query.
So it's like a divide and conquer strategy for queries.
Exactly. This not only improves accuracy and efficiency, but also makes it easier to spot and fix any errors or vulnerabilities along the way.
This is getting pretty intricate. Okay, so we've covered basic queries, sneaky SQL injection attempts, those edge cases, and now complex multi-part questions. Anything else we need to consider when testing these LLM-powered systems?
Well, we also need to think about ambiguous or poorly phrased queries. The kind of stuff humans say all the time, like, find orders where the amount is $1,000.
Right, like what does that actually mean? It's exactly 1,000? More than?
Yeah,
Less than?
exactly. Human language is full of nuance and ambiguity, and we need to teach our systems to handle that.
So how do we do that? How do we teach a system to deal with, the messiness of human language?
It all comes down to robust error handling and clear user feedback. We need to train the system to recognize those ambiguous phrases and ask for clarification. Like, hey, I'm not sure what you mean by $1,000. Could you be more specific?
So instead of just guessing, the system pauses and asks for more information.
Exactly. It's all about ensuring accuracy and avoiding those misunderstandings that can happen with with us humans and our love for ambiguity. And speaking of avoiding those misunderstandings, there's another fascinating layer to this whole security testing thing, is the idea of using AI, to test AI.
Wait, AI versus AI. That sounds like something straight out of a movie.
It might sound futuristic, but it's a real technique called LLM augmented fuzzing. Basically, you use one AI system to generate all sorts of crazy, unexpected queries, the kind of things a human tester would never dream up.
So you're intentionally trying to, break the system.
Exactly. You're throwing these wild inputs at it to see where the weaknesses are.
I like it. It's like having a robot toddler banging on the keyboard, but with a purpose.
That's a great way to put it. And the cool thing is, we can train this fuzzing AI to be context-aware, so it's not just random gibberish. It creates inputs specifically designed to push the limits of our query system, within a certain domain or task.
That makes sense. So it's like a specialized testing team, but made of AI.
Right. But let's say we've done all this testing, found and fixed the vulnerabilities, and we're finally ready to launch our LLM-driven query system into the wild.
Okay. What happens then?
That's when the next phase kicks in, real-time monitoring and logging. It's like installing security cameras and motion sensors in your house.
So we're not just setting it and forgetting it.
Definitely not. You need to keep a close eye on things, even after the system is live.
Makes sense. But what are we actually looking for?
Well, you want to monitor all those incoming queries for any signs of malicious intent. This might involve searching for patterns, that match known attack signatures, or maybe analyzing the structure of those queries, looking for anything unusual. And if something does trigger an alert, you got to have a plan in place to respond quickly.
So it's not just about preventing attacks, but also about being ready to deal with them if they happen.
Exactly. And that's where comprehensive logging is crucial. You need detailed records of all those queries, their natural language inputs, the SQL queries generated, the results returned, everything. This gives you that valuable audit trail to investigate incidents and, see where you can improve.
It's like having a black box for your query system so you can go back and reconstruct what happened if things go wrong.
Precisely. Which brings up another important point, the need for continuous testing and improvement. Remember, LLMs are constantly evolving, learning from new data, new interactions.
But the security landscape is constantly changing too.
Exactly. It's like a moving target. You got to stay vigilant, stay ahead of those potential threats.
Okay, so how do we do that? How do we keep up with, with all these changes?
Well, one key technique is that AI versus AI approach we talked about earlier. As these systems become more sophisticated, so will the ways to attack them. We got to be proactive, anticipate those attacks, and develop countermeasures.
It sounds like a constant arms race, but with AI as the weapon.
It's definitely challenging, but exciting at the same time. We're at the forefront of a new era in security, where AI is, it's playing a big role on both sides.
That's pretty mind-blowing. And it makes you wonder, about the ethical implications of all this. Our source document talks about using AI to break AI. What does that mean for the future of security in this AI-driven world?
That's a really good question, and to be honest, it's a bit unsettling, isn't it?
Yeah, it's like opening Pandora's box, but instead of evils, we're unleashing all these new challenges.
Exactly. As we build these increasingly powerful AI systems, We got to be mindful of those potential risks and think about security right from the start, build those safeguards into the design itself.
So it's not just about making secure systems, but also about fostering that culture of security awareness, that constant improvement.
Absolutely. We need collaboration between developers, security experts, and users to create this secure and resilient ecosystem.
It sounds like it's going to take a team effort to navigate this new world of AI.
It definitely will. But I think we're up for the challenge. And while
Yeah.
we're on the topic of security, there's this thing called the OWASP Top 10.
The OWASP Top 10. What's that?
It's basically like um, a hit list of the most common web application security risks.
Mm-hmm.
Things like, cross-site scripting, SQL injection, broken authentication, all that stuff.
So even though we're talking about AI, these older vulnerabilities, they still matter.
Oh, absolutely.
Yeah.
Like building a house, right? You can have all the fancy smart home gadgets you want, but you still need a strong foundation. Those basic security principles, they're still the foundation.
So we're basically combining those traditional security practices with new AI-specific safeguards.
Exactly.
What would those be? What are some of those AI-specific safeguards?
Well, one key area is prompt engineering. It's the art of crafting those natural language questions, making sure they're, well, less susceptible to manipulation, teaching the system to be picky about the questions it accepts.
So we're not just like throwing any random question at the AI.
Nope. We got to be careful about how we phrase those questions.
Makes sense.
And another thing, we need to validate the AI's output. Just because it gives us an answer doesn't mean it's the right one, or even a safe one.
It's like double checking your work before you hit send.
Exactly.
Wow.
We got to make sure the AI isn't being tricked into giving us bad information.
So basically, don't blindly trust the AI.
Right. A healthy dose of skepticism is always a good thing. Always question assumptions, verify information, and, stay informed about those potential risks.
It sounds like we need to stay on our toes. This deep dive has really given me a lot to think about, from SQL injection to, AI battling AI, prompt engineering, continuous testing, monitoring. Wow, we've covered a lot. So what's the main takeaway for our listeners today?
I think that the key takeaway here is that security for these LLM-driven systems, it's not a one-and-done deal. It's a constant process.
Yeah.
You got to be vigilant, adaptable, and always stay ahead of the curve.
It's an ongoing journey.
Exactly. And it's a journey we're all on together as we navigate this exciting world of AI.
Well said. And on that note, I think it's time to wrap up this deep dive. It's been fascinating. Hopefully our listeners are feeling, inspired to keep learning about this ever-evolving field of AI security. Until next time, stay curious, stay secure, and keep those questions coming.